Turning to problem 3, this is where you're going to get the motors to run at different speeds, forward, back, make turns. These are the design shapes I want you to have the robot perform. And I would highly, highly, highly advise that you save your files at this point. Save it as a new file name, because the programs you're going to write, especially in this activity, you can use on the final project. It will be the building blocks you need. So then problem 4. This is a really fun, interesting one. We've done a very similar activity a few weeks or months ago. We took the compass on our phone and we made a 90-degree turn. The robot has a compass, and so we can load up the Zumo compass heading file, and we can read out the compass heading for the robot. Okay. Now I'm asking you to go through and to make readings using your phone as the target value or the gold standard measurement, and then your robot measurement as what you measured. And if we pull that code up, compass heading, upload that, you're again going to have to scroll to the top here. You want to read through the comments. Okay. You're again going to have to calibrate the compass. Okay, so in the void setup now for the compass heading file and for the sensor array file, I have calibration sequence. Okay, and I've noted every line of code that is specifically related to the compass calibration, I've commented as unique to compass calibration. The reason being, if you are to take a compass and use it in your final project, you need to grab those lines of code and put them into your final project program, okay, in those spots under the void setup, okay? Or if you want to combine this file with somebody else's file who is using the sensor array calibration, you want to take their lines of code that say unique to sensor array calibration and put them in your code here. So this is really just identifying specifically which lines of code relate to the calibration of the compass in this file or the calibration of the sensor array. We need to calibrate the sensor array and the compass if we're going to use it. Okay, so I've calibrated it, and now I have an X heading and a Y heading, and as I rotate the robot around, I'm rotating around 360 degrees. I get to the crossing 0 mark, and I'm going to flutter back and forth, right, between 360 and 0 until I get past that, right? What I want you to do is to document, and I give you this file on Blackboard, is to document your readings as you rotate the robot around and compare them to the ideal, which is the phone. And in a perfect world, there's a one-to-one relationship. I turn the robot 90 degrees, the phone registers 90 degrees, the robot registers 90 degrees, right? Reality is, you're probably going to get something like this orange line, okay? And as you fill in this data, you're going to have this trend line starting up here. The trend line is a calibration curve that you could say and put it into your robot code that would help eliminate some of the errors in your calibration or in your compass readings. So at 60 degrees, I'm actually measuring an 80-degree heading, right? That's off, right, by 20 degrees. At 90 degrees, I'm actually measuring 110 degrees. So if I were to put the 110 degrees into this equation for x, put it through that equation and come out as y, it would be y right on the dashed line there. It would be closer to the blue perfect ideal line, right? Orange is what we're measuring the robot as, blue is the ideal, dash is our trend line. So I would want to smooth out or get that robot measured value, put it through my equation to get rid of some of the error, and spit it back out along the dash line. That would be a more accurate measurement for compass heading. Okay, so this is something we can do. We can generate an equation that then we can use in our program to filter out or remove some of our error in our measurements, because the compasses are going to have a lot of error. One other note, if you get up to your 360 or at your 0 and you actually have something that looks like this, right? Or something that looks like this, right? Those two beginning and end values are going to skew your equation a lot. Those are outliers. What we can do to make our equation more practical and accurate, we can just zero that to 0. We can set that to 360, right? And we have a more realistic equation then, as opposed to something that is really drastically off, right? So just some pointers. This is a really interesting part of the activity. This is going to need to be, you're going to want to calibrate your sensor and then also find an equation to even further remove that error for your compasses especially.